The given are x of t is equals to a times 2 alpha t minus sine alpha t, and y of t is equal to a times 1 minus cosine alpha t. And we are asked to solve for this. We have to find the tangential acceleration and the normal acceleration. And we also have to find the maximum of the normal acceleration. So first, we have to find the velocity, which is a vector, which means it has a magnitude of v, and the direction of t, which is the tangent vector. And we know that acceleration, we note that dv over dt, equation, which means that getting the normal, get the derivative of v with respect to t, which gives us d over dt vt plus v dt over dt. And we note that in getting the normal vector, it is equal to dt over d small t over the magnitude of dt over d small t, which means that dt over d small t is equal to the magnitude of dt over dt times n, and kappa is the magnitude of dt over d small t over the magnitude of v, which means that the magnitude of dt over d small t is equal to the magnitude of v and times kappa, which gets us d over dt magnitude of v t plus kappa magnitude of v squared n, and dv over dt is the tangential acceleration, and kappa v squared is equal to the normal acceleration. Now, solving for the tangential acceleration, we must first find the velocity, which can be computed by getting the square root of the sum of the squares of the first derivative of x and y. The first derivative of x is equal to d over dt of the given, which is a times 2 alpha t minus sine alpha t, which is equal to, we take out the constant, which is the capital A, and multiply it to the derivative of 2 alpha t minus the derivative of sine alpha t. And the derivative with respect to t of 2 alpha t is equals to 2 alpha, and the derivative with respect to t of sine alpha t is equals to cosine alpha t times alpha, which gets us the first derivative of x is equal to a times 2 alpha minus cosine alpha t times alpha, and we square that, and we distribute the square to a squared, and we distribute the square to a, and 2 alpha minus cosine alpha t times alpha, which gets us a squared times 2 alpha minus cosine alpha t times alpha squared. And using FOIL method, we get this a squared times 4 alpha squared minus 4 alpha cosine alpha t times alpha plus cosine squared of alpha t times alpha squared, which gets us a squared alpha squared times 4 minus 4 cosine alpha t plus cosine alpha t. Now we get the first derivative of y, which is getting the derivative with respect to t of the given a times 1 minus cosine alpha t, which gives us a times the derivative of 1 and the derivative with respect to t of cosine alpha t. The derivative with respect to t of 1 is equal to 0, and the derivative with respect to t of cosine alpha t is equal to negative sine alpha t times alpha, which gives us the first derivative of y to be a times sine alpha t times alpha, and we square that, and we get a squared sine squared of alpha t times alpha squared. Now, in getting the velocity, we must get the square root of the square of the first derivative of x and y, which gives us this a squared alpha squared times 4 minus 4 cosine alpha t plus cosine squared of alpha t plus a squared alpha squared sine squared of alpha t. And after we factor out a squared and alpha squared, which gives us a squared alpha squared times 4 minus 4 cosine alpha t plus cosine squared of alpha t plus sine squared of alpha t. And we know that there's a trigonometric identity which is sine squared theta plus cosine squared theta is equal to 1, which means that cosine squared of alpha t plus sine squared of alpha t is equal to 1, which we will add to 4, which gives us 5. And now we have the velocity is equal to a alpha square root of 5 minus 4 cosine alpha t, which gives us that if we find the derivative of velocity with respect to t, we get the acceleration, which means that we have to find the derivative of what we got previously with respect to t, which means we have d over dt times a alpha square root of 5 minus 4 cosine alpha t is equal to a alpha d over dt times the square root of 5 minus 4 cosine alpha t. And we can rewrite the square root of 5 minus 4 cosine alpha t to be 5 minus 4 cosine of alpha t raised to 1/2. And now we solve for d over dt, 5 minus 4 cosine alpha t 1/2. And by using chain rule, we first get the derivative of the entire t, which gives us 1 over 2 square root of 5 minus 4 cosine alpha t. And we get the derivative of the what's inside the parentheses, which is the derivative of 5 minus the derivative of 4 cosine of alpha t with respect to t. And the derivative of 5 with respect to t is 0. And the derivative of 4 cosine alpha t with respect to t is negative 4 sine alpha t times alpha, which gives us 4 sine alpha t times alpha. And after this, we get the answer for the derivative of 5 minus cosine of alpha t raised to 1/2 to be 2 alpha sine alpha t all over square root of 5 minus 4 cosine alpha t. And now we get the tangential acceleration. We just multiply this answer to the constant a and alpha, which gives us 2a alpha squared sine alpha t over 5 minus 4 cosine alpha t. Now we solve for an. Now we solve for the normal acceleration. We know that the particle is moving in we know that the particle moves in a two-dimensional orbit, which means that it has a component of we know that the particle is moving in a two-dimensional orbit, which means that this is the visualization of its movement, and the tangential acceleration is tangent to the orbit of the particle, and the normal acceleration is what makes the particle to curve, which means that its acceleration is the hypotenuse of the tangential acceleration and the normal acceleration, which is here. And to compute for the normal acceleration, we use Pythagorean theorem, which is a squared is equal to the normal acceleration squared plus the tangential acceleration squared, which gives us the normal acceleration is equal to the square root of the square of the difference is equal to the square root of the difference of the square of the acceleration and the tangential acceleration. To solve for the acceleration, we first have to find the second derivative of x and y. We already solved for the first derivative of x and y, which means it will be easy for us to get the second derivative, which we just have to get the derivative again with respect to t. And for the second derivative of x, we get the derivative with respect to t of a times 2 alpha minus cosine alpha t times alpha, which gives us a, which is the constant. We take it out, and then we distribute the derivative to 2 alpha and cosine of alpha t times alpha. The derivative of 2 alpha is equal to 0, while the derivative of cosine alpha t times alpha, we take out the constant alpha, and we have the answer of negative alpha squared sine of alpha t. We square that, we get a squared alpha raised to the fourth sine squared of alpha t. And for the second derivative of y, we get the derivative with respect to t of a sine alpha t times alpha, which we get the constant out, which is the alpha and a, and we get the derivative with respect to t of sine alpha t, which gives us a alpha squared cosine alpha t. And we square that, we get a squared alpha raised to the fourth cosine squared of alpha t. And now, to get the acceleration, we take the square root of the sum of the squares of x, of the second derivative of x and y. So we get square root of a squared alpha raised to the fourth sine squared of a alpha t plus a squared alpha raised to the fourth cosine squared alpha t. We factor out a squared and alpha raised to the fourth, we get the square root of a squared alpha raised to the fourth times sine squared of alpha t plus cosine squared of alpha t. And we know that the trigonometric identity of sine squared theta plus cosine squared theta is equal to 1. We can conclude that sine squared of alpha t plus cosine squared of alpha t is equal to 1. We now get the acceleration, which is a alpha squared. Getting the normal acceleration, we have to get the square root of the difference of the square of acceleration and the tangential acceleration. We already have the acceleration and the tangential acceleration. We have to square the acceleration, which gives us a squared alpha raised to the fourth, and the square of the tangential acceleration is 4a squared alpha raised to the fourth sine squared of alpha t over 5 minus 4 cosine alpha t. And we subtract the tangential acceleration from the acceleration and get the square root, which gives us the normal acceleration of a alpha squared square root of 1 minus 4 sine squared alpha t over 5 minus 4 cosine alpha t. Now we have to determine at what times in the orbit the normal acceleration has a maximum. And we know that the normal acceleration has a maximum if its derivative with respect to t is equal to 0, which we just have to get the derivative of what we got with respect to t and equate it into 0. We take out the constant and get the derivative of 1 minus 4 sine squared of alpha t over 5 minus cosine alpha t raised to 1/2, because it is a square root. And using chain rule again, we get the derivative of this, which is 1 over 2 square root of 1 minus 4 sine squared of alpha t over 5 minus 4 cosine alpha t, and get the derivative of inside the parentheses, which is the derivative with respect to t of 1 minus 4 sine squared of alpha t over 5 minus 4 cosine alpha t. And the derivative with respect to t of 1 is equal to 0. And now we have to get the derivative of 4 sine squared alpha t over 5 minus 4 cosine alpha t, which is here. We take the constant out, which is 4, And using this rule in derivative, we get 4 times alpha sine 2 alpha t times 5 minus 4 cosine alpha t, and we subtract 5 alpha sine cube of alpha t over 5 minus 4 cosine alpha t squared. And we now we multiply this answer to here and here, which gives us a alpha squared 2 times a sine 2 alpha t 5 minus 4 cosine alpha t minus 4a sine cube of alpha t over the square root of 1 minus 4 sine squared alpha t over 5 minus 4 cosine alpha t times 5 minus 4 cosine alpha t squared, and we equate that to 0. And we know that for this equation to be 0, the numerator has to be 0, and for this numerator to be 0, we can notice that the sign, if it's equal to 0, the whole equation is equal to 0, which means that sine of alpha t should be equal to 0, and the value of alpha t should be a value that makes the sign 0, which is n pi, and we manipulate the equation to get t, which is equal to n pi over alpha.